Okay, for geometry 9.3, we are learning about similar right triangles. So we're going to create a similarity statement for the three triangles ABC, ACD, and BCD, and they're the pictures of the ones right over here. This has a weird shadow right here. Sorry about that. It's from the ladybug up here. But anyway, so looking at this triangle, what they're basically saying is we're going to take this really big one and we're going to separate them into two smaller ones. Excuse me. And if you take one triangle that's a right triangle, see the right angle up here at C, and you pull them apart based on its altitude. And again, if you forgot what an altitude is, I can't remember if we've talked about it or not this year, but it's the height. Remember, if you did base times height to find area, you can't use one of the slants. You have to use the actual height. And so if you draw the height in to a triangle from the top straight down, it makes a right angle, and that is called the altitude. So that little piece that makes the height. So if you cut a right triangle down and form its altitude, that means you can take them and separate them out. And these two triangles are also similar to this triangle. So they would have the same angle measures and the sides would be proportional. So let's say we did that. We took triangle ABC, which is here, and it would become similar to which two other triangles? And they're right over here, so let's just make sure we line them up correctly. From A to B to C, I went down the hypotenuse and then the short leg. So when you name it, I would go hypotenuse, short leg, so ACD. So ACD. And it's also similar to the other one. And again, you need to go, I went hypotenuse, short leg. So I would go down the hypotenuse and the short leg. So CBD. Okay, so we just proved the right triangle similarity theorem. And it says if an altitude, so go ahead and write this in. If an altitude, which I just talked to you about what an altitude is. If an altitude is drawn from the right angle of a right triangle, to the hypotenuse. So just to make sure this is making sense to you instead of just a bunch of words. Excuse me. The altitude is drawn from the right angle to the hypotenuse. So see what we did up here? We took it from the right angle and drew it straight down the altitude to the hypotenuse side. Okay, if it's drawn to the hypotenuse, blah, 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 then the two smaller triangles formed, the two smaller triangles that are formed, which are the ones we brought down here, the two smaller ones, this is the big one, are similar to the original, and to each other. Okay, that's going to be really important because you're going to have to be able to see the big triangle, and then your brain is going to have to be able to see them separated out too and then turned to where they're going the same direction. I have found over the years of doing this, if you are paying attention to which one the hypotenuse is and then which one the short leg is and which one the long leg is, you can kind of find the other sides that are similar to it a little bit quicker, a little bit easier. Okay. So we have to identify the similar triangles in the figure on this right, so over here, and then write a similarity statement. So here's the big one. Let's go ahead and write that one. We're going to identify all three. So triangle what is similar to triangle what is similar to triangle what. So I would start with the big one. So the big one, if I'm just going to go hypotenuse, short leg again. So if I start at the corner and I go up the hypotenuse to S and then down the short leg, that is triangle RST. So I'm going to say triangle RST is similar to, let's go with the medium one next. So if you can picture this medium triangle, so don't look at the tiny one at all. The medium one, if I could just go hypotenuse to short leg, this becomes the hypotenuse now. So the right angle is over here. So this is RT, and then the short leg is to U. So RTU. And that is similar to the tiny triangle, which the hypotenuse of that is this one, ST. So if I was looking for hypotenuse and then short leg would be SU, so TSU. Okay, if you can kind of figure out a way to see all three of those triangles, it will help you. Okay, something you learned a long time ago about the word mean. The arithmetic, I know it looks like arithmetic, but it's actually pronounced arithmetic. It's weird. The arithmetic mean, that's the one that you've learned your whole life, between two numbers like R and S is defined to be you add all the numbers and then you divide by how many are there. So if we had three numbers, if we had R, S, and T, it'd be R plus S plus T divided by 3 because you divide by how many numbers are there. That's the typical mean you guys have learned how to do forever to find the mean. But today I'm introducing you to the geometric mean. So let's write geometric mean. You do it slightly differently. So it is, if you have our two numbers like R and S, they would satisfy this equation. You'd put X that we don't know diagonal from each other, and then the two numbers we do know also diagonal from each other in the other way. So it makes kind of a ratio. And if you cross multiply X times X, you have X squared. This is really hard to see. Oh, it's just copied too light, sorry. But if you are cross multiplying, because that's how you do proportions, so X times X, you have X squared. R times S, you have RS. Then in order to get X by itself, right now it's being squared. So you're just solving this equation, basically like you would solve an equation. I don't really need to draw that line, but to get X by itself, you would square root it. And what you do to one side, you're also going to do to the other. So in order to get X by itself, you square root the two numbers that we were multiplying. So X would be whatever the two numbers are multiplied together and then taking the square root of it. The reason that comes into play is because when we move these, we maybe know one number or two numbers, and you're going to use it twice because the long leg of this big triangle might end up being the hypotenuse of this one. So you might have to use it twice so that we can find the geometric mean. Okay, let's try it with two numbers, 12 and 24. So if you have the geometric mean of 12 and 24, you just set it up to be X over 12 equals 24 over X. The order doesn't matter, and you really don't even need to show this work. If you knew that our two numbers are getting multiplied and then our two X's are getting multiplied, it would be X squared is equal to whatever 12 times 24 is, which I don't know. It is 288. So the answer is whatever the square root of 288 is, which I'm going to think that that does not come out evenly, but let's just try it. Nope. So we're just going to leave it the square root of 288. I mean, I guess it could be about 17 if it wants to know what it's about, but this is the more specific answer. Okay, let me tell you why you might be using that. So let's look at these. So if I gave you like that this CD in here is 10, let's just say it is. I wrote really tiny, but that's supposed to say 10. And DB is 5. And we'll just say this one's X. So if you're trying to find this length of X, and the only thing we have is the altitude, and X plus 5 for the whole hypotenuse, that's a problem. You can't really find X when you're missing too many other things. You can't even use Pythagorean theorem. Well, I guess you could. You could do it twice. You could find Pythagorean theorem of this one, and then Pythagorean theorem. Well, no, you still can't because we don't know this one. So there's just no way to solve it unless you break them apart and use the same numbers you have in two different ways and set them up with a similarity statement like the side lengths on the ratio. So let's go down here and fill in. Here, I'm going to zoom in a little bit. Let's fill in. If we knew that the altitude is 10 and between D to B is 5 and between A to D is X, let's fill in what those are in these other two smaller triangles. So We know that C to D is 10. So C to D right here is 10. And also C to D in this one is also 10. Okay, if we know that D to B is 5, then we have D to B here, which is 5. And then we have A to D is X. So from here to here is X. So this is why it becomes much better to break them apart and to know how they go, because now we can just do the bat and the ball. So we can say X to 10 equals 10 to 5, and then we'll be able to solve it. So X to 10 equals 10 to 5. And sometimes, like, and this is a not good example for geometric mean, because sometimes you have X in two of them. And so that would be where you would square root it and find the final answer. But in this one, we actually have 3 of the 4 numbers. So X times 5 is 5X, 10 times 10 is 100, divide both sides by 5, and X would be equal to 20. So we would never have been able to solve it with just this much information unless you knew to separate these and that all 3 are similar. So now we know X is 20. Okay, so let's do really quickly a couple more definitions. We're getting down to it here. Geometric mean altitude theorem says in a right triangle, the length of the altitude drawn from the right angle to the hypotenuse I'm going to abbreviate hypotenuse as hype. I know you guys like that. Is the geometric mean. So that actually is how we're going to find the geometric mean. So that is it. That ends up being the geometric mean of the lengths of the segments. But we're not going to need to write all of that because I hope that makes sense. All right. Now let's talk about it based on not the altitude, but the leg. So this says in a right triangle again, actually we also need to know it already has the altitude drawn in. So width and altitude drawn. So we can't do it unless the altitude is also drawn in, because that's what's going to separate them out. So in a right triangle, if the altitude has been drawn, the length, there we go. The length of each leg is the geometric mean. I'm going to abbreviate that to geomean. It is the geometric mean of, I know you guys will be able to figure this out, but it is technically of the length of the hypotenuse and the segment adjacent to that leg. So the length of the hypotenuse, I'm going to abbreviate that to hype again. And the segment, it's hard to explain which leg this is. So it is the one, it's the segment adjacent to that leg. We'll look at an example here so you guys can put it all together. Okay. So here's what it is saying. Here is your, and you can pause the video and go back and write that out if I went a little too fast. But here's what it's saying. It's saying, here's your ABC, big triangle. If you square it, it's equal to AD times BD. So AD times BD. And same thing here, like it works the other way around too. So that was the altitude theorem. For the two legs, the leg theorem is take CB this time and square it, and it's equal to DB times AB. Or AC squared, if you're going the other leg, equals AD times AB. Okay, so this is like kind of your key that we're going to use. And now I want you to like put it all together over here in these two problems. So it says we're going to compute the unknown values. So in A, we have X, Y, and Z to find, and all they gave us is 20 and 10. So we've got a little work to do, but if you guys know that the short leg and the hypotenuse, the short leg, you guys know this is probably a 30, 60, 90 triangle. We learned that yesterday or in 9.2 because the short leg is half or the hypotenuse is double, is two, this is x and this one would be 2x. So let's go back to that lesson because if you know that this is a 30, 60, 90, just based on that the short leg is 10 and that the hypotenuse is 20, then this special formula in here is going to be, look back at yesterday's or 9.2 notes if you need to, but if it's a 30, 60, 90, then this is going to be x root 2. So, or x root 3, I'm sorry, x root 3. So 10 is x, 20 is double 10, and the long leg would be 10 root 3. So without even doing any math, we already know what y is. Okay, let's separate them out those because we're going to need to find what z and what x are too. So here's what I would do. We know that, let's do this one. So let's set it up as hypotenuse over short leg. So I'm going to, just because I want to keep that straight, I'm going to make myself a little key over here. I'm going to do hypotenuse over short leg. So I'm going to do that ratio in all three triangles. So hypotenuse over short leg. So in the big one, my hypotenuse is 10 plus x. And my short leg on the big one is 20. Okay. In the medium-sized one, my short leg over, or my hypotenuse over short leg is, my hypotenuse would be z over my short leg is y, but we know that one's 10 root 3. Or you could put it as y, doesn't matter. Okay, and then in the tiny triangle, my hypotenuse is 20 and my short leg is 10. So we already know that everything on the top is double the things on the bottom because these are all equal. So, or they're not equal, they're on the same scale factor. So if this is 20 to 10, whatever this is going to be double whatever's down here. Whatever this is going to be double whatever's down here. So knowing that, we can solve for x already because 20 is on the bottom, so we're going to need 40 up here, which means x has to be 30. Okay, and then we can find z. I'm just going to choose to say, I mean, it doesn't matter, but we can do 20, let's see. I'm going to stay away from that number. I'm going to do x plus 10, yeah, over 20. Let's do that. I'm going to do this one to this one. I guess we have to use x root, or 10 root 3. So I'm going to cross multiply these. So 10 times z is just 10z. 20 times 10 root 3 is 200 root 3. Remember, if it's outside, it can be multiplied by outside. Inside can only be multiplied by other insides. So I need to get z by itself, so I'm going to divide both sides by 10. And z would be equal to, that just simplifies. So that's going to end up being 20 over 1, or just 20 root 3. So z would be equal to 20 root 3. We also probably already would have known that, wouldn't we? Because whatever my short leg is, the long leg is double. So 10 root 3, this one we should have known was going to be 20 root 3. Okay. I am going to ask you to right now pause the video and try B by yourself. I'm going to really quickly just write out what the answers are, but I want you to try this on your own first. So go ahead and pause the video and try to find X, Y, and Z now. Okay, I'm going to write out what the answers are, and if you were a little confused, you can ask me about this one in class. But to check and make sure you guys got the right answers, X should have come out to be 2. Y should have come out to be I think square root 15 if I did my work right. And then z should have come out to be square root 10 if I did my work right. I'm also going to just show you really quickly what I did so you can freeze this. I set it up differently at first, so ignore all that. But here is what I got on this part. And if you are still confused after you look over your work, if you got something different, you can definitely ask me about it in class. Okay, let's turn the page into our very last problem. No, longer than I thought. We're almost done. This one has to do with, This one has to do with this picture over here on the right, this guy that's like looking at a cliff. He's trying to decide based on his height and these two right triangles that are similar, how high the cliff is. We know from here to here is 5.5 feet. We don't know how tall it is from here to here. So we're gonna have to find that one and then obviously add them together to find the total height of the cliff. Okay, I would probably set this up maybe short leg and then long leg, because if I look at this tiny triangle, the littlest one, I know I have the short leg and I have the long leg of it. I don't have the hypotenuse, but I have the short leg, long leg. So I think that's how I'm going to set it up. I'm going to do short leg to long leg. And I know on the tiny triangle, I have 5.5 and I have 28. So they're both in feet, aren't they? Yes, I have 5.5 and 28. So if I'm doing short leg to long leg, I'm going to do the medium-sized triangle, the one that's on top here. So short leg I have, it's 28. Long leg is what I'm looking for. So that's going to be my x. So short leg is 28, long leg is x. Short leg is 28, long leg is x. Be sure you put them lined up with short leg, long leg. That's why I keep saying it like that, because you need to be consistent. All right, and this is going to be a geometric mean because you are, well, we've already talked about that. But 5.5 times x is 5.5x. 28 times 28 is something. 784. All right, 784 divided by 5.5 comes out to be about 142.5. It does say something about rounding to the nearest whole foot, but let's not round yet. Let's keep it about 142.5 for now, because we'll round it to the nearest whole foot after we add it to the part that we know. So x is 142.5. Now we just need to add the total together. So we're going to add the 5.5 to that, and that will be about 148.0, so about 148 feet. About 148 feet. Okay, there you go.